Greetings, logic students. Here we go again, an Intro to Logic, pandemic version. Coming to you from my meditation nook in St. Petersburg, Florida. So today we want to talk about set theory, right? And make use of a fellow named John Venn, who helped us to think about that. John Venn developed a way of graphically representing the meaning of Aristotle's categorical propositions, and these have come to be known as Venn diagrams. In a Venn diagram, a circle is used to represent a class, a set, or a category. And here's our man, John Venn, looking very dapper, right? All logicians have to have beards, we see. I'm part of that tradition. Now, the way of thinking that John Venn developed grew out of what is called set theory, right? Which began to be developed at this time. So first we need a brief explanation of what is called simple or naive set theory, as philosophers and mathematicians generally think of them. Now, if you think about the world, right, in set theory, you think about it as full of things. There are people, there are starfish, there are mountains, there are lightsaber replicas, there's glasses, there's all kinds of things. And these are just what we've learned to call referents or particulars when we talked about concepts, right? And they're just individual things, or what Aristotle calls beings or substances. And in addition to these things, these set theorists thought, there are sets that contain these things. So suppose we start with the individuals John Venn, George Boole, and Aristotle, three logicians. Now, in addition to them as they actually existed, we have the set of them, written like this, with, we'll call them squiggly brackets. A technical term logicians have, squiggly brackets. And we read this as, when you see the brackets, you read it as the set of John Venn, George Boole, and Aristotle. And this way of listing a set is called extensive notation, right? And you can relate this to comprehension and extension that I talked about before. Another word for comprehension is intension, okay? Now, there's another way of doing it too, is what is called intensive notation. And this would be read as the set of X, such that X is a palm tree in Pinellas County. Now, with extensive notation, we simply list each individual in the set. But with intensive notation, right, we specify the set by listing a feature common to all members of the set. It would be fairly tedious to list every palm tree in Pinellas County by longitude and latitude, right? We'd have to go around with our phone and mark the coordinates, and it would be a long job to list all the palm trees in Pinellas County. So instead, we can simply do it like this, with giving the intension or the comprehension, right, that specifies the attributes that apply to the members of the set. Now, if the set is small, we could also do it both ways, right? We could give the extensive notation here, John, Paul, George, and Ringo, or we could give an intensive notation, the set of all X, such that X is a beetle. Now, these are not two different sets, but are simply the same set expressed in two different ways. Now, we also say that a set contains its members, and that the members belong to the set. And a set is defined by nothing else than what members it has. So if X and Y are sets, then they're the same set, if and only if they have the same members, right? So this is the same set because they only have the same members. Now, one set can also be a subset of another set. So if X is a set, then Y is a subset if and only if all members of Y are also members of X. So here we can see that Bilbo, Thorin, and Gandalf, and Balin, Bifur, and Bofur are both subsets of Bilbo, Thorin, Gandalf, Balin, Bifur, and Bofur. They're also what are called singleton sets, with just one member. And here we have one of those. That's the set of Bilbo, which is a subset of all three of these sets. But it's not a subset of this set. And you wouldn't want to confuse the set consisting of Bilbo with Bilbo himself. That would be the particular Bilbo, and that's something very different. Now, Venn began to think of all this using circles, because he thought, as he said, it was a beautiful way to do it. And I think it is too. So suppose we think of the set of material things, right? Now, this circle, right, is the set of every material thing that exists. But we also have the idea of an empty set, right? This means there are no material things, right? And to do that, we shade out everything in the circle. So this would mean that the set of material things has no members at all. We also talk about what is called the domain of discourse or the universe of discourse. And when we're talking about everything that exists, past, present, and future, it would be called the universal domain, and is the set of everything that has, is, and will be existing. Or we could constrict our domain to one set of things, like the domain of animals, and so forth. Now, typically, this is represented by a square around the circle class. So using our example of material things, in the diagram, the space inside the circle represents the entire class of material things. And what's outside the circle represents everything that's not a material thing. And the class of everything not in the set is called the complement of the set. Now we have this with the box, but as a matter of convention, I could just draw a circle and then the whole page would be like the box, right? So you don't always have to draw the square. It's sort of implicitly there. Now using Venn's setup, we can diagram various claims. For example, if we put an X inside the circle, and the X represents that there's at least one thing, right? That's a material thing, right? There's at least one thing that's a material thing. And here, we could make the claim that at least one thing is not a material thing. Here, we could make the claim there are no material things. And here, we're making the claim everything is a material thing. There's nothing outside the set of material things. So this means there are no non-material things. Venn used two circles to represent two classes and how they relate. And here's where we begin to understand how we can diagram Aristotle's categorical statements. In this Venn diagram, the circle to the left is used to represent the subject class, while the circle to the right is used to represent the predicate class. Subject, predicate. Now these numbers are not usually in the circles, but I've just put them here to help us talk about it. Notice also that I'm now leaving off the squares around the circles, which we simply assume to be present, since what it represents, after all, is the entire universe outside those circles. Because unless we specify otherwise, the universe of discourse is by default taken to be the universal domain. Now, a categorical proposition has two terms which represent two sets, or classes, or categories, as Aristotle would call it. So in a Venn diagram, a categorical proposition is represented by two overlapping circles. The circle to the left is always used to represent the subject class, this side, while the circle to the right is always used to represent the predicate class. So let's look at this diagram, right? Everything in section 1 stands for the class of things that are human beings but not living things, such as dead people. 2, right here, stands for the class of things that are both human beings and living things. 3 here stands for the class of things that are living things but not human beings. So that would be all the animals and plants, and if they're aliens on other planets, it would include them. And 4 stands for the class of all things that are neither human beings nor living things. And this is a vast class that includes all inorganic things in the universe, ranging from specks of dirt to rocks to stars, and even includes your car or the backpack you carry your books in. All right. So Venn's genius was to figure out how to diagram A, I, E, and O propositions. And he did this through his beautiful circles. Now, consider all Jedi are Force-sensitive beings. If we let S equal Jedi and P equal Force-sensitive beings, that gives us the universal form all S or P. If we then look at the circles, and here everybody's mind works different ways, right? This might seem a natural way of thinking to you, or it might not. And I have to admit, sometimes when I'm trying to think this way, I feel like I've fallen down the rabbit hole into Wonderland. But it just turns out that in Wonderland, everybody thinks logically. Well, in the normal world, we don't. So it turns out we're really the ones that are upside down, right? We're really the ones walking around on our heads. While in Wonderland, everyone's walking on 2 logical feet. So if we look at the 2 circles, we have the class of S and the class of P. And what this diagram shows us is there's not any S's outside of the P circle. We black everything out, and we're saying there's not an S outside the P circle. So all S are P. Some Wookiees are starship pilots, right? We're going to let S equal Wookiees and P equal starship pilots, and that gives us the universal form, some S or P. Now, what this thing is claiming is there is at least one Wookiee that is a starship pilot. In logic, some means at least one. There may be more, but we know there's at least one. And in fact, this is a true statement because we know there's at least one Wookiee that's a starship pilot, the great Chewbacca. And to do this, we show an X means an existence claim. Right? So there is at least one X that is in both the S and the P class. Here we have the claim that no Jedi are Sith. So we're going to let S equal Jedi and P equal Sith, and that gives us the universal form, no S or P. And the way we indicate that is, where the 2 circles overlap, we're saying there's nothing. There's nothing that's both an S and a P. Right? There's nothing there. Okay? That's an easy one, I think, to understand. And finally, we have some Jedi are not humans. Right? If we let S equal Jedi and P equal humans, we have the universal form, some S are not P. Right? And we indicate that by saying there's at least one S that's not a P. And we know some Jedi are not humans. Here's the great Plo Koon, one of my favorite Jedi, who is not human, right? But he's a Jedi. Now, each of our 4 types of propositions has both a quantity, it's going to be universal or particular, and a quality, it's going to be affirmative or negative. In terms of quantity, universal propositions, or A and E propositions, refer to every member of the subject category, while particular propositions, I or O propositions, refer to at least one member of the subject category. So quality then refers to what we call category inclusion, either affirming or denying that one category is wholly or partially included in another. So consider the following with me. All wolves are mammals has the form all S or P, and it's an A proposition, and it's called a universal affirmative. And this statement claims that all members of the subject category are included in the predicate category. This means all wolves are members of the category of mammals. The second one, some birds are parrots, is an I proposition. It's a particular affirmative, and it has the universal form, some S or P. Now, this statement claims that some members of the subject category are included in the predicate category. Now, it's important to note that some in logic specifically means at least one, and that is all it means. This means that at least one of the category of birds is included in the category of parrots. Oh, my throat's getting dry here at 5:30 in the morning. Our third one, no plants or animals, is an E proposition, or a universal negative, which has the form of no S or P. And this statement claims that no members of the subject category are included in the predicate category. They have no members at all in common. So no members of the category of plants is included in the category of animals, and vice versa. And finally, we have the O proposition, a particular negative, such as some tree are not oaks, which has the form some S are not P. This statement claims that some members of the subject category are not included in the predicate category, so there's at least one member of the category of trees that is not part of the category of oaks. So let's put it all together with our Venns, right? An A proposition is a universal affirmative. Its universal form is all S or P, and we diagram it like this. An I is a particular affirmative. It has the universal form some S or P, and it's diagrammed like this. An E is a universal negative. It has the form no S or P, and it's diagrammed like this. And an O is a particular negative, and it has the form some S or not P, and it's diagrammed like this. Now consider the exercises in the book, which you're going to be working on for me, right? And these are the kinds of things you'll see on the exam too, right? So we have here some snowmen are permanent lawn fixtures. So we let S equal snowmen and P equal permanent law fixtures, and we put the little X there, right? Now notice over here though, I'm going to want you to do the level 1 multiple choice questions, the level 2, and then there's something really cool here. There's an interactive Venn diagram exercises. So you want to go ahead and do these too. And the software will tell me that you've done it, okay? And the homework, of course, here will be on the honor system. I'll send you the key. And here's another example of the kind of thing you might see on the test, right? For each of the following propositions, identify them as A, I, E, or O and give their form. Give their quantity, and quality. Identify the subject and predicate classes, and then create a Venn diagram of the proposition. Example, some cats are annoying creatures. So we have our answer. It's an I, some S or P, it's particular affirmative. The subject class is cats, the predicate class is annoying creatures, and there's the diagram. There's at least one cat that's an annoying creature. And there's exercises you could do if you want to practice it, right? Just freeze the YouTube video and work on it if you wish. So that's another adventure in Wonderland. I hope you've enjoyed falling down the rabbit hole with me as we learn to walk on our feet instead of standing on our heads, as we usually do. I'll see you next time with more Wonderland fun. Thank you for your kind attention.